Okay, today we're working out of the book Elementary Principles of Chemical Processes, 3rd edition. We're doing problem 2.13. I'll read the problem statement. A horizontal cylinder drum is 2 meters in diameter and 4 meters long. The drum is slowly filled with benzene. Density equals 0.879 grams per centimeter cubed. Derive a formula for W, the weight in newtons of the benzene in the tank, as a function of H, the depth of the liquid, in centimeters. Okay, so 2.13. Let's draw the situation that we've got. We've got a drum that's laying down. Oh, and they provide this picture as well. It's filled with a certain amount of liquid, and the liquid height is H. The drum is 2 meters tall, and the length is equal to 4 meters. Diameter equals 2.00 meters. That means the radius is equal to 1 meter. The density of benzene is 0.879 grams per cm cubed. Okay, so we want the weight. So the weight is the force times the mass times the acceleration due to gravity. The mass is also equal to the density times the volume. Okay, so we need to solve what the volume of a section of a circle is. Okay, so the formula for the area of a section of a circle is equal to 1/2. You can just Google this. Sine theta r squared, where the circle section looks something like this. You have the center of the circle here. You are taking a section of the circle right here. The highlighted section is the section of the circle. Theta is the angle right here. That's theta. The radius, r, is right there. Okay, so that's a section of the circle, and in our drawing, the height would be right here, little h. Okay, so we need to solve an equation that puts theta in terms of r and h, because we know r and h, but we don't know what theta is, and theta is going to change as the drum fills. Let's examine our drawing here and look and see what theta equals in terms of r and h. Okay, so we know that the cosine of the blue triangle is equal to theta over 2. Okay, so the cosine of theta over 2 is equal to the adjacent, which is r minus h, over the hypotenuse, which is r. You can see, I'll color this in red, you can see that r minus h, so r is the distance from here to here, but the adjacent is r, the red, minus h. Adjacent is the green arrow. R is the red arrow, minus h, distance, gives us the adjacent, r minus h. Okay, now if we look at the hypotenuse of this triangle, we see that the hypotenuse of the triangle is equal to r as well, right there. So r minus h, and in blue, r. That's the cosine. Okay, so now we have theta in terms of r and h. So theta equals 2 times cosine of r minus h over r. Great. Okay, so now we move on to the volume. So we know that the volume equals the area of the base, which is the yellow portion. That's the area that we just solved for. And we have an expression for the area right here. The area of the base times the length, which is L, area of the base times the height. Okay, so that equals 1/2 theta minus sine theta r squared L. Okay. So then let's give ourselves a little more room here and substitute in our expression for theta and say the volume is equal to 2 cosine r minus h over r minus sine 2 cosine r minus h over r, and then close all that up, r squared L. Okay. And the force we need to substitute in, and remember we're solving for the force here. So now we have V, we know what G is, and we know what rho is. Okay, so since we know all of these terms, we can now substitute in our expression for the force. And the force equals rho r squared LG over 2 times 2 cosine minus 1 r minus h over r minus sine 2 cosine r minus h over r, and close all this up. Okay, so that's our expression for the force. Now, in the problem statement, they asked us to put this into a more empirical form where we're substituting in the actual numbers for all of these terms, and we're making an expression that uses h in centimeters and spits out force in newtons. So let's do a conversion for substitute in all of our numbers and do a conversion so that it yields newtons force unit. We're going to change all this front matter into newtons. So we've got 0.879 grams per centimeter cubed divided by 2, 1 meter squared, 4 meters, 9.81 meters per second squared. And now we do our conversions, kilograms per 1,000 grams, and convert our centimeters into meters. And the centimeters cancel, the grams cancel, the meters 3 cancels, and we are left with kilogram meters per second squared, which is equal to a newton. Okay, so we're just left with newtons. Okay, and we multiply all this together, and we get 1.72 times 10 to the 4, and that's in newtons. Now we need to deal with this term in the brackets right here. This term in the brackets is unitless. You just need to make sure that the units of R and the units of H are the same. And so it's told us that we needed to have H in units of centimeters, so we need to make sure that R is in units of centimeters as well. Okay, so they gave us R in units of meters. R is 1 meter. If we go back here and look at the beginning, R is equal to 1 meter. So we need to convert that into centimeters, and that equals 100 centimeters. Okay. So the units of R and H need to agree. So we'll substitute in our expression now and say 2 cosine and 100 minus H divided by 100 minus sine 2 cosine minus 100 minus H over 100. And there you have the solution to the problem. When you plug in H as centimeters, it will spit out a dimension that's in newtons because we solved for newtons. So this is our force expression in that takes H in centimeters and returns force in newtons. Okay. Thanks for joining me for this problem. If you noticed any errors that I made, please let me know and I can make a correction and update the solution. Thanks for your help. Talk to you later. Bye.